And let's begin. Hello everyone, my name is Amrit. Welcome back to this Learning Python from Scratch course. And today is the 14th webinar in this series. Previously in the series, we have covered the basics of Python, and we have kind of did the majority of it, and now we're just looking at implementing what we know in real life problems, and just so we could get a little bit of practice and just so we could learn a little bit more about computer science in general. So the previous 3 or so webinars, we've been looking at sorting algorithms, an algorithm just being a series of instructions or just a bunch of code. So we've been looking at code that is meant to be used for sorting an array. And today we're going to rediscuss some of the reasons why this is important and start looking at searching algorithms. Most likely in tomorrow's webinar, we will be looking at how to input and output from a file in Python, which could be very important and it's worth going over. So tomorrow's webinar would probably be fairly important in that regard, just so we learn how to input and output from a text file in Python. But today, as I said, we will be looking at searching algorithms. So if I share my screen, there we go. Let's just make sure that my microphone, yep, okay, cool. So unfortunately, the challenge I gave yesterday, I couldn't get my answer to load up on this computer. I think the site I used to transfer it to this computer was probably down or something. So I couldn't get the new challenge or the code for yesterday's challenge here. So what I'll do is I'll just skip it for today, and I'll show you, hopefully get it working by tomorrow, and show you my answer for yesterday's challenge and give you a new challenge tomorrow in tomorrow's session. Now, as I said today, let's look at why we have been looking at sorting algorithms and why they're important in computer science, and we will spend today looking at searching algorithms. Now, so let's just quickly revisit why we did this in the first place. Now, if you kind of remember, the explanation I gave in the first session we used to learn bubble sort, I gave you an explanation why it's important that we have sorting and searching algorithms. Now, reason being is, let's say you have an array being the most simple simple data type or data structure we would be looking at. So let's say we have an array. The entire idea of this is so that, let's say you have an array of 10 cells big, so 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. So let's say you have this array and it's all filled with numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all fine. A computer, if it needed to go through this array, wouldn't take too long at all. A couple milliseconds, if that. Now let's assume that this array has, I don't know, 100,000 cells. 100,000 cells, and now let's say the computer needs to find a specific value in one of these cells. As you could probably imagine, this will take a computer forever if it were to go one by one. So the initial way and the most basic way to go through an array is called linear search. And all linear search says is this your value? If it is, return it value, and then we're done. Otherwise, move to the next one and check if this is what we want. Nope, is this what we want? Nope, is this what we want? Nope, is this what we want? So on and so forth until we reach the end. So that's linear search. And as you could imagine, linear search is very inefficient for very large arrays or very large data structures. So if you wanted to find, let's say these were all names, and this is a name starting with A, and this is a name starting with Z. Let's say you had 100,000 of these. as you could imagine, if you wanted to find someone whose name started with a Z and they were all the way at the end, linear search will take forever in computer time in order to find that and tell you if it's in the database or if it isn't, or if it is in the database, what position it's at. So the solution to this is binary search. Binary search is by far the quickest way to look for something in an array. And that's the only main search algorithm we'll be looking at and how to program today in Python, just so we could apply our programming skills. But binary search has a catch that the array needs to be sorted. Now, when it comes to searching algorithms, binary search is by far one of the best algorithms out there, just because it's a pure divide and conquer algorithm, and it's pretty much almost guaranteed to get you to whatever you're looking for pretty quickly. That being said, sorting algorithms are a completely different story because they depend, the time they take depend on how it's been coded and how the data is inside the array when you start off. So sorting algorithms can be a bit tricky when it comes to making a really efficient one, but when it comes to searching, binary search is by far the best way. Now let's get into how binary search actually works. So let's assume we have an array. Let's see if I could draw a biggish one. Well, it kind of not small over there. 1, 2, 3. Let's quickly just fill it in. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have an array of 20 values or 20 cells. So binary search is fairly straightforward. Let's say we want to look for the value 6. Is 6 a good value? Let's say we want to look for the value 7. 7 should be better. Let's say we want to look for the value 7. Well, what binary search says is because we know the array is sorted, let's go bang into the middle. So since we have 20, middle would be between 10, well, no, the middle is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so since we have an even number, the middle is technically over there because you have 10 values here and 10 values there. So it's up to the programmer how you want to do it. Let's just say we go with 10. So what binary search says is go into the middle, in this case 10, and first check if this value is what we're looking for. Well, 10 isn't 7, so no, it's not what we're looking for. Then what binary search says is if it's smaller than what we're looking for, check away everything bigger. Or if it's bigger than what we're looking for, check away everything smaller. So since 7 is smaller, what we do is we get rid of everything bigger than 10. And on top of that, we also get rid of 10. Reason being is because we know this isn't what we're looking for. Now, just by one comparison, we've eliminated half the data or half the array in order to look for what we're looking at. Cool. So and now it's just rinse and repeat. So binary search says go into the middle again. So since we have 9, middle would be 5. Go into the middle. Is this what we're looking for? Nope. What we're looking for is bigger, so get rid of everything smaller than this. Fair enough. Now what binary search says is do this again. Go into the middle, which in this case, like we discussed, would be 7 because there's 4 values. So the middle is here. Let's just go to the left of it. Is this what we're looking for? Yes, it is. We found it, and then we could return this value or the position or whatever we want to do with it. So that was binary search. So to find 7, binary search took us 1, 2, 3 comparisons. In linear search, it would have taken us 1, 2, 3, 4, 5, 6, 7 if it was sorted, and at maximum 20 if it wasn't sorted, assuming 7 was over here. So as you can see, binary search is a divide and conquer algorithm, which basically means that you get rid of half your problem at once every single time. Divide and conquer tend to be the most powerful algorithms for that, because of that quality, that they get rid of half, or they halve the problem every single time. And binary search is no different. And this is essentially the main searching algorithm that is probably used in most systems. How it's programmed could probably be done better in some cases. So essentially, binary search is used everywhere, but the way it's programmed is obviously dependent on the programmer, and how efficient it is could always be improved. We're just going to look at a basic way of implementing binary search that returns the position of which the element is at that we're looking for. So let's get into this. Is there anything else you need to mention about binary search? So yeah, that's the basic idea of binary search, and it's fairly straightforward to get. So worst case scenario for binary search is, well, in this case of an array with 20 values, would be 1, 2, 3, 1, 2, 3, 4, 5, would be 5-ish. So I do believe, and I'm not, I don't entirely remember this, but I do believe worst case scenario for binary search is log base 2 of however big your array is. So this is the maximum number of comparisons it will take for binary search. Maybe there's a +1, but essentially the fact that we're doing log base 2 of n basically means we'll be able to find whatever you're looking for pretty quickly, even if your array is a pretty big number. So let's get into how we would actually code binary search. So let's go back into Python. Let's bring both these up and let's do this. Cool. So this is binary search. So let's quickly do linear search. Linear search is very straightforward. Linear search. There we go, linear search. Of course, we're looking for an event, an element, let's just say x, in an array A. So what linear search says is basically just a for loop. So for I in range len A, what we want to do is if x is equal to a I, return I, else, nope, we don't want else. We just want return -1. There we go. So essentially what -1 means is we couldn't find whatever you're looking for in this array. So linear search is fairly straightforward. So for I in range, whatever the range is, whatever the length of the array is, so go through the array. If x is equal to the element we're on in the array, return the position it's at. Otherwise, if we go through the for loop and don't find what we're looking for, return -1, which basically means we couldn't find your element in the array. So binary search, let's write its method for it. So binary search, and we're looking for A in, in array A, we're looking for X. Cool. Now there's a couple different ways you could probably do binary search. So let's kind of see how we're going to approach it. So let's kind of remember that in binary search we go into the middle and compare if what we're looking for is, if the value we're on is what we're looking for, if it's bigger or smaller. So let's do that first. So if, first we need to find out what the middle is. Is equal to the length, int of the length of A divided by 2. If you don't remember, this basically, since divided by 2 could give us 0.5, the int part just chops off the 0.5, rounding it down for us, essentially. So we got the middle. So if, now that I think about it, yeah, okay, that may be a slight problem. Don't worry, we'll get into it when we face it. So if A is equal, so the middle in this case is equal to what we're looking for, return the middle. Where's my space gone? Return the middle. Otherwise, we know that it's either bigger or smaller than this, so let's figure that out. If I also realized that that is a mistake. By the way, if you are watching this on YouTube, you can come in live to ask questions while I'm doing it. I do have the chat open. So else if this, well, we could just copy paste this. There we go. So let's do it the other way around. If x is bigger than or equal to the middle, we're gonna do something. We'll get back to that. And if x is less than, well, we don't need to do the equal to. We know if it's equal to, it'll run this. So if it's less than or equal to the middle of A, what is going on today? Yeah, so if it's less than or equal to the middle, then what we're going to do is also do something that we haven't decided yet. Now, the entire thing that I just thought of is the way I was about to go through it is we want the position to where it's at, which basically means we're going to need 2 more methods. Actually, no, we're just going to need 1 more method. Yeah, we're just going to need 1 external extra method. So let's get into it, and here's why. So let's create this method. I'm just going to call it binary search rec, because we're going to do it recursively, just so it's straightforward. Probably isn't the most efficient way of doing it, but it's fine. So we want A, we want the array, we want X, and we want the position. So I'm just going to call it pos. And what I mean by position is, if we go back to this, well, let's say we're at 10 here. Let's see how much I could undo. I want to undo all those squiggly lines. So let's undo all the way there. There we go. So let's say we're at 10 because of our algorithm, and we find out that what we want is bigger than 10. Well, of course, we're going to get rid of all of this, but now the problem is our array or our program is going to treat 11 as 0, when in reality 11 has position 10. So the entire reason for pos is we just keep track of what the initial position is. Actually, we don't need to. Yeah, we probably don't need to. There probably is a way of doing it without that we could try after we do it this way. So this is just me gonna showing you that there are multiple ways of doing it. But for now, let's just do it like this. So we are going to give it the position, the beginning position, just so when we return it with the fact that we know where exactly it is in the array. So yeah, so we need the position, and what we're going to do is we're going to do the exact same thing here. We're going to do the exact same thing here, but instead we're going to call it self. So if it's bigger than a, what we also need is a condition to see if the array is empty. If the array is empty, of course, that means it doesn't exist, which will probably be better in this. So let's add that in both of these. So if, nope. So if the user just right off the bat gives us an empty array, so if A is empty, then return -1, because we know it's empty, we don't need to do anything. We need 2 equal signs here. But over here, let's do the exact same thing. So if A is empty, return, return -1. -1 just means that we can't find it. And let's change this to elif. Else if it's what we're looking for, return middle, the number. Well, we don't have middle, so that's going to be a problem. So middle in this case is the exact same. It's just all of this. But we're going to return middle plus the position. So we're going to return the position of what we're at plus how much to get to the middle. So that's fine. Now let's fill in these. So if it's bigger than what we're looking for, and what we write here is going to be the same as what we write here. So if it's bigger than what we're looking for, well, what we're going to do is return. Let's copy this so we make sure we spell it correctly. Yep. So what we're going to return A from middle, because we know it's greater. We're gonna return it for middle plus 1 onwards till the end. That should be fine. That's one thing we're going to return. The other thing we're going to return is x, what we're looking for, and the position is going to change. So the position is going to be the position of what we're at currently plus what middle is, plus middle. So hopefully that kind of makes sense. So the position, our new position is always going to be what the previous position was plus how far we have to go to get to the current middle of the subarray or whatever we're looking at is. That should be fine. And over here will be return the exact same thing pretty much. So A, instead we're going to go to the middle -1, middle -1, yep. We're going to be looking for x, and the position is going to be just pos, because it's still going to be greater than what we're currently at. So this is basically the scenario in which we get to, let's say we cancel off all of this, we get to 16, I think, and then let's say we're looking for 14, we get rid of all of this. Pos is still going to remain 10 because it's still there. If it was greater than what we're looking for was greater than 16, then it would have been the pos, which is 10, plus the value of 16, the middle in this scenario. So let's go back to this. Yeah, so that should be fine. And theoretically, we could just copy this in here with this indented properly. There we go. And we could copy this here, just changing what pos actually is. So in this case, the position is going to be middle plus 1, plus 1. Would it be plus 1? Maybe just middle. We'll play around with it, and in this case, the position is just going to be 0. So let's see if this works. The only way we know it works is by testing it. So let's print the binary search. The binary search of array A, which is just going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And in this case, we're just going to be looking for, let's just say, position 8, which should give us 1 less than 8, so 7. So when we run this, we should see 7 on this side, and if we get 7, that means it works. We got 6. So somewhere we are, wait, is it position 6? No, it's definitely position 7. So 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so somewhere we are returning 1 less than what we should be returning. Yeah, so let's take a look. So we're adding 1 to this. X, middle. If it's greater than, we go for middle plus 1. Yep, that's fine. Onwards, middle. Yep, that's fine. Middle minus 1. I think that needs to be that. I think that could be the. This doesn't include the middle. This does, which is why we plus 1, 0. That's fine. That's fine. That's fine. The position we give in the middle plus middle, that's fine because of that. So why is it giving us 6 and not 7? Well, debugging, so let's print out everything that is relevant at each stage. So what we're going to be printing out is all of this. We are also going to be printing out all of this here. And we're going to be printing out all of this. These are the main parts. And we're going to be printing out all of this. Now let's see where we are getting an issue. Cool, so we're looking for, so this is our array. Why is it bigger? We're looking for 8. Right off the bat it went bigger. So if x, what we're looking for, is bigger than a, well, we don't want equal to, is bigger than a at the middle, we print this, which is an issue. Hold on. We go a middle, yeah, because it's bigger, so the middle onwards. This basically means, oh, we aren't printing the right thing here. That makes sense. Same thing here, yep. No, that seems fine. There you go, we're printing the right thing now. So we're looking for 8. Our current position is 0. And we have this array. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I think we do need the -1 because we're at 10. 5 here. Oh, it's 5, so we need to go middle +1. Why is that? That's interesting. Position plus middle. I think because of this +1, that's probably why. That's fine because we get an array which is bigger, so we do need +1 here. But by the looks of it, we also need a +1 over here, which means we need a +1 over here. But we are getting 10 here, so the only thing I want to know right now is what the middle is right off the bat. So what we are going to do is print A at the middle. Let's run this quickly. 11. Okay, so 11 was the middle, not 10, so which means this is perfectly fine. That makes sense then. So let's get rid of all our print statements. We are getting 7 now, which is perfectly fine. So that's one print statement we need to get rid of. That's another print statement we need to get rid of. That's another one. That's another one. And that's another one. Cool. So that was binary search with Python. Let's run this one more time just to make sure it's fine. Yep, position 7. Let's give it a bigger position, so something like 19. Let's run this, run module, okay. Position 18, yeah, just one less in it. Let's just see 20, so the extreme. Run module, okay. There we go, 19. Let's run it. Oh wait, let's put it something that isn't in here. So let's say 90. We should see -1. There you go. -1 basically means it's not in there. Hopefully that has made sense to everyone, and me showing you how to implement it in Python is also making sense. This is just my thought process on how I program, and of course the way you would do it would probably be different. But the main part of this is just to show you real-life problems in computer science and just a generic solution to them. This is using recursion. If you do it without using recursion, it will probably be more efficient and more efficient memory-wise and just better overall. Yeah, so tomorrow we will be looking at file input output in Python, which is a big one. And after that, we will probably take one last look at sorting and searching algorithms just to show you something interesting. And then next week, we will start object-oriented programming in Python and go over concepts of object-oriented programming and all that type of fun stuff. Or we may flip it around, or we will do the final webinar on this tomorrow. It just depends on today was a shorter webinar than usual, just because searching algorithms are fairly more straightforward than sorting, because of the fact that sorting algorithms get complicated depending on what the array initially is, which is why we always look at worst case scenario when it comes to sorting algorithms and searching algorithms. That being said, linear search is the most basic searching algorithm. It's just a simple for loop, and binary search could get a little bit complicated, but by far it's the most efficient searching algorithm. That being said, there isn't much else for me to say other than hopefully you've understood and kind of enjoyed this. And of course, you're practicing using the challenges we give. So yesterday's challenge will be, I will be giving its answer tomorrow. Hopefully the site gets up and running and I could access my files again. Other than that, I don't see any questions in chat. So if you are watching on YouTube, please do come in live UK 1 o'clock time to ask any questions if you have any. If not, that's great. Just make sure that you are practicing. The only way you're going to get better is by practicing. And yes, tomorrow it will be up on Facebook what exactly we will be doing in hour or so. But that being said, thank you everyone so much for watching. If you're on YouTube, please do come in live for the webinar link. It will be, I think, on our Facebook page, SP Components. If you're watching this live, this will be on YouTube afterwards as a video that you could watch, rewind, and pause, just so you can understand what's being done and how it's being done. Hopefully, seeing me where you think the error is, and just making sure that numbers are what you expect them to be, when you expect them to be, and if they aren't, kind of figure out why they aren't, and that's probably where your error is. So yeah, thank you everyone so much for watching, and we'll see you in tomorrow's webinar, where we will probably be finishing off this topic by kind of comparing how efficient each one is compared to each other, with some very special Python inbuilt libraries. And I guess I'll introduce libraries tomorrow as a generic thing, but it's not too complicated. So thank you everyone so much for watching. I'll see you tomorrow in tomorrow's webinar. Bye-bye.